Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IQRAM bin ZULFIKRY, student number 2019-230358. Today I will be presenting about my final year project proposal, which is optimization of Ti-6Al-4V green part using palm stearin based binder. In this project, titanium alloy powder of Ti-6Al-4V is mixed with binder 60% WT% of palm stearin and 40% WT% of polyethylene for metal injection molding. Injection molding parameter has been optimized using response surface methodology. Next, we will be moving towards the introduction. Metal injection molding combines the geometric intricacy familiar from plastic injection molding and is an advanced technology for the mass manufacturing of high standard parts. There are various processing stages involving in metal injection molding, including mixing, injection molding, debinding, and sintering. To ensure that the process is successful, overall, it is crucial to optimize each of these steps and choose the right beginning ingredients such as the powder and the binder. Next, we will be moving forward to the metal injection molding process. Um, Finally, powder metal is combined with binder material to generate a feedstock. The final product is created as solidifying and shaping the feedstock. The process step: binder to produce powder to produce a feedstock mix. To form the feedstock into the desired shape, injection molding machine inject the liquid feedstock into them. The green part or the molded component is first left to cool before being taken from the mold. The removal of the binder then occurs utilizing a variety of techniques such as catalytic process, thermal furnace, and etc. The binder is only partially removed. Next up are the debinding and sintering procedure. The latter involve compacting the shaping material with either pressure or heat, but it is always end up before substance turn fully liquid. Next, we'll be moving forwards towards problem statement. The product quality must be given top consideration. The strength of the material is a crucial first consideration in this project. The material peak strength will reveal how effective it is. It is possible to create material with the maximum density and greater strength by using processes like debinding and sintering. It might be exceedingly challenging to manufacture some part of or small component in large quantity. Therefore, it is crucial to examine the quality by changing some of the applied parameters. Response surface method technique were applied to this work. Optimizing the experiment parameter is the reason. This method also cuts back on expenses and time. Additionally, the most important parameters and their optimal interaction must be found. This is crucial to raising the quality of the final result. Next, we'll be moving towards the objective. This study will look into the following objective, which is to study the use of pump steering binder system in metal injection molding, to design the experiment of injection molding using response surface method, to optimize the metal injection molding parameter in order to get the highest green strength of Ti-6Al-4V. Next, we'll be moving forward to scope and limitation. The scope of this study is to find the best injection molding setting parameters. So by altering the chosen variable Ti-6Al-4V, will have the maximum green strength possible. This variable includes holding pressure, injection speed, powder loading, mole temperature, injection pressure, and injection temperature. Additionally, the interaction between injection pressure, temperature, and powder loading were investigated. For maximum moldability, avoidance of sharp corners, thin transition, utilization of draft angle and corner radius are all necessary. The debinding constraint imposed by a particular feedstock determine for the design restrictions such as the maximum part thickness. Typically, the maximum cross-sectional thickness of most metal injection molding part is less than 7 millimeter. Next, we'll be moving forward towards the metrology, which has three. That is preparation of its stock, size machine, and Minitab, which is the software. The feedstock is a spherical Ti-6Al-4V particle with a density of 4.38 gram per centimeter cube, was combined with 40 PS and 40 WT percent polyethylene and at 150 Celsius for 1 hour. The mixing operation was carried out in a Sigma blade. The Battlefield BA250 CDC injection molding machine was then used to inject the feedstock for the tensile strength machine to determine the strength and deformation behavior of material up to the point of fracture. A tensile tester or tensile testing machine is utilized. Tensile strength is measured in unit of pressure, most frequently in Pascal. For structural engineer and material producer, the strength to weight ratio is a key factor. Next, the Minitab, which is the software that we use to analyze and calculate the best parameter to optimize this project, to optimize the metal injection molding. Minitab is a data analysis is done using a software program called Minitab. It is widely employed in many different fields, including manufacturing, education, and healthcare. Users of Minitab have access to tools for statistical analysis such as ANOVA, regression analysis, and hypothesis testing. Next, we will be moving towards the expected result. This is my result from the data that I collect using Minitab. I can use the response surface method in the analysis of variance table. The p-values of the hot bar T multiplied by the hot bar T with the dwell time multiplied by dwell time, and hot bar T multiplied by dwell time are significant. This can consider reducing the model, remove the terms that are not significant. This can analyze see the relative magnitude of the various impact, visually identify the significant effect using the Pareto plot of the effects. Furthermore, we can observe that hot bar T multiplied by dwell time has the biggest influence because it stretches the furthest. The point on normal probability plot do not follow a straight line in the residual plot. This may be resolved by reducing the model. That is all from me. Thank you.